I think of this, all the time when I think about probability and statistics. There's a rich history and tradition. And again, Laplace did a huge service kind of making this a mathematical, quantifiable science. And a lot of the thought leaders at that time really changed kind of our world from this astrology to, scientific astronomy, kind of alchemy to chemistry, divination to probability and statistics. Huge sea change in how we think about the world. Weather is inherently chaotic. It's a chaotic dynamical system. And this is one of the things I really want to point out, is that these probability and statistics systems oftentimes actually are fundamentally deterministic. They're not actually random. If I think about a coin, this is my fair coin. If I flip this coin, this technically is not a random system. This is governed by force equals mass times acceleration, F equals ma. It has wind resistance, mass, inertia. It's under the effect of gravity. This is a deterministic physical system that technically I could model on a computer with equations and do a pretty good job of predicting. But as far as I'm concerned, as a human observer, there is too much uncertainty in my measurements, in my ability to model this in my head. So for me, a coin flip is a random or uncertain event that I have to model probabilistically. Okay, and I can use this to generate random numbers, kind of, because it does have this kind of chaotic randomness in the wind resistance and its motion. And so a lot of these systems, turbulence, gas dynamics, weather phenomenon, those are actually fundamentally deterministic dynamical systems. They are predictable. Often the chaos in that dynamical system means that my prediction horizon is finite, and after some point, for all intents and purposes, I have to model it with probability models. So there's this fine line between deterministic systems that I could model if I had enough information, and us actually having to model them probabilistically because there's so much uncertainty in our physics models, in our measurements of the initial conditions, of things like that.